So in this objective, we are going to use the half angle identities to help us find values of different angles. So for example, find the exact value of, so my first one here, the cosine of 112.5 degrees. So the first thing that's important to do in these problems is to realize 112.5 is not something that's on the unit circle. But if I were to double 112.5, it would actually be 225, and 225 is on the unit circle. So this happens to be the same as finding the cosine of 225 degrees divided by 2. And that is what allows us to use the half angle identity. So the half angle identity that we're going to use from the form, from that paper I have, is the cosine of alpha over 2 is equal to plus or minus the square root of 1 plus the cosine of alpha over 2. Now the plus or minus we're going to have to figure out at the end. Are we dealing with the positive part or the minus part? And so we'll take care of that here in a minute. So the first thing I'm going to do is I'm going to plug into my formula. So this cosine is going to be equal to plus or minus the square root of 1 plus, in this case my 225 is my alpha. So we're going to have 1 plus the cosine of 225 degrees, all that divided by 2. Okay, so now when we go to pick whether we want the positive or the negative, we have to look at our original angle. So if you look at our original angle here, 112.5 degrees is in quadrant 2. And in quadrant 2, the cosine is negative, which means we have to take the negative case here. So now if I kind of rewrite here, my answer is going to be negative square root of 1 plus the cosine of 225 is minus 1 over the square root of 2, all over 2. And we would like to rationalize this a little bit. I don't mind that there's a square or a fraction under the radical sign, but I do mind the little tiny fraction. So to rationalize this, I'm going to think about multiplying the whole entire top by the square root of 2, which means I also have to multiply the whole entire bottom by the square root of 2. So this is going to become negative, big square root. This little square root of 2 has to be distributed to both of these pieces. So it's going to end up being root 2 minus 1 all over 2 root 2. And then, so I'm okay if you leave the answer like that. Alex might have you do a little bit more work to get rid of that. But I'm okay if you leave the answer that way. That's a totally perfect answer. Not a problem with it. So let's try another one. So we'll go here to the next page. So B, the sine of 3 pi over 8. And so again, 3 pi over 8 is not something that's on the unit circle. You could convert it to degrees if stuff makes more sense for you in terms of degrees. But if I were to double that, right, if I took 3 pi over 8, I'll do it over here on the side, and I multiplied it by 2, I would actually end up with 3 pi over 4. And 3 pi over 4 is on the unit circle, so that's good. So this is actually the same as the sine of 3 pi over 4 all over 2. And just like before, we need the formula from the sheet. So the sine of alpha over 2, again, it has this plus minus part. So plus minus the square root of 1 minus the cosine of alpha over 2. So if I use that here, we are going to end up getting, so my we want to first figure out what alpha is. So remember, alpha here is this 3 pi over 4. So this is going to be plus or minus the square root of 1 minus the cosine of 3 pi over 4 all over 2. We have to figure out what quadrant we're dealing with so we can figure out whether we're going to take the positive part or the negative part. 3 pi over 8 is in quadrant 1, and everything's positive in quadrant 1, so we're dealing with the positive case here. So it's going to be plus the square root of 1 minus, so the cosine of 3 pi over 4 is root 2 over 2, or 1 over root 2. You could write it either way, like I did it on the last side, all over 2. And so again, I want to get rid of that little fraction. So if I multiply the top by 2 and the bottom by 2, I end up getting, and I don't have to keep writing the plus sign, right? So I end up getting 2 minus root 2 all over 4. And that I could break down into the square root of the top. So 2 minus root 2 divided by the square root of 4, which is 2. So square root of 2 minus root 2 all over 2. So in these problems, when you use the half angle identities, if you happen to take a half angle identity that has the plus or minus, remember you always have to go back to the original one. And not everyone has a plus or minus. The tangent does not have a plus or minus, so you don't have to, well, I should say there's half angle identities for the tangent that do not use the plus minus, and so those you don't have to worry. But all the other ones that have this plus minus, you have to go back to the original beginning angle and see what quadrants it is in to determine whether your final answer should be a positive or a negative.